Hi, boys and girls. In this episode, we'll be looking at fractional numbers. Let's dive in and have some fun. Our objective is to use addition and subtraction to compute with fractional numbers. Let's play a game of fraction grabber. Can you grab or select a shape which has not been split into equal sizes or parts, has exactly a half shaded, is more than a half shaded, is less than a half shaded, has been split into quarters or eighths, has been split into thirds or sixths? All right, let's look. So exactly in a half, okay, that's exactly in a half. All right, less than a half, mm, less than a half. Well, of course, this is less than a half. Okay, that's a quarter. This is 1/4. This is a half. So that would be, this is gone, this is gone. Oh, this is a more than a half. This one is more than a half. This would be 3/4. All right. Less than a half, we have that. Has been split into quarters or eighths. Well, we have the quarters here. All right, let's see. 1, 2, 3, 4, 5, 6. This one has been split into thirds or six. Well, we have the sixths here. Okay, that's two. Uh, 1, 2, 3, 4, 5. Yes, six. And we have 4/6 there. Okay, so that's gone. Quarters, eighths, sixths. Has not been split into equal. I'm not seeing that one. Not been split into equal parts. I'm not seeing that one. If you see that one, then you help me with that one, okay? Explore. Can you identify the following? Into how many parts is the figure divided? What fraction represents each of the equal parts? What fraction part of the whole is shaded? What fractional parts of the whole is unshaded? Now, this is not so clear for me. Okay. Let's see. We'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 4 fours would be 16. So let's say that it is divided into 16 parts. Okay, so 16 parts. So 16. And how many parts are shaded? 1, 2, 3, 4, 5, 6, 7. It says 7. Let's go over this again to make sure. I have 1, 2, 3, 4. All right. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. How many parts now shaded? 1 and 2 and 3 and 4 and 5 and 6 and 7. I think that's it. Okay, how many parts is the whole divided into? Okay, so 16. What fraction represents each of the equal parts? So that would be 1/16. This would be 16. And then it says what part of the whole is shaded. This would be 7/16. Okay, and then 4, what part of the whole is unshaded. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9/16. Now if we have 9/16 and 7/16, we add these two, we should get 16/16, which is the whole. Okay, explain. Fractions. Fractions tell us how many parts of a whole we have. A fraction can be identified by the fraction bar that is between both numbers. Fractions have a top number, or what is called a numerator, and a bottom number, which is called a denominator. Here's an example. We have 4/5. So here we have the fraction bar, and we have the top number 4 being the numerator. We have the bottom number 5 being the denominator. The bottom number or denominator tells us how many slices make up a whole pie, while the top number, the numerator, tells us how many of those slices we can have. 1. Adding and subtracting fractions with like denominators. When fractions have like denominators, we do the following. A. Add or subtract the numerators. B. Write the sum or difference over the common denominator. C. Simplify if possible. Now here's an example. 3/16 plus 1/16 would be equal to 4/16. Now 4/16 can be reduced by dividing both the numerator and the denominator by 4, which would give us 1/4 or a quarter. So 3/16 plus 1/16, we just add the numerator, so 3 and 1 would be 4, over 16 or 4/16. 4/16 can be reduced to a quarter. Example B, 7/12 minus 5/12 would be equal to 2/12. Now the factor we could use would be 2, and then we would get 1/6. Adding and subtracting fractions with unlike denominators. When fractions have unlike or different denominators, we need to find the LCM or the LCD, which is the least common denominator. Now, you rename each fraction as the equivalent fraction. Then we add or subtract the numerator and then simplify if possible. Let's look at this example. We have 1/3 plus a half plus 1/8. Now the LCM of 3, 2, and 8 would be 24. So the equivalent fraction for 1/3 would be 8/24. The equivalent fraction for the 12 would be 12/24. The equivalent fraction for 1/8 would be 3/24. When we add all of those together, 8 and the 12, we get 20, 20 and 3, 23/24. Example B, 11/12 minus a quarter. The LCM would have been 12. So 11/12 stays as 11/12, and the equivalent fraction for a quarter would be 3/12. So we would take from 11/12 3/12, and we would get 8/12. We can reduce this by using 4. 4 into the 8 will go 2 times, and 4 into the 12 goes 3 times. So we end with 2/3. Adding and subtracting mixed numbers. If the denominator is different, it is renamed as an equivalent fraction. We add and subtract the whole numbers. So here we have example A, B, and C. So we have 7 and 1/3 plus 3 and a half. So the LCM here would have been 6. The equivalent fraction for a third would be 2/6. The equivalent fraction for a half would have been 3/6. And we would have 7 and 3 giving us 10, and 2 and 3 giving us 5. And we keep the denominator 6. So we would have 7 and 2/6 plus 3 and 3/6, giving us 10 and 5/6. We have 8 and 4/5 minus 2 and a half. This can be rewritten as 8 and 8/10 minus 2 and 5/10, because the LCM here would have been 10. All right, so if we have 8 and 8/10 minus 2 and 5/10, the 2 from the 8 will give us the 6, and the 5 from the 8 will give us 3. We keep our denominator 10. Example C, we have 10. and we're going to take from it 4 3/4. Now we'll take 1 out of the 10, and that will leave us with 9. And that 1 that we have taken, we'll change that to 4/4. So we are going to change this 10 to 9 and 4/4. Now 4/4 is 1, and 1 and 9 would be 10. So we're just writing the what? Writing the 10 as a fraction that has fourths in it. Okay? Now we are able to complete. Now 4 from the 9, the whole numbers, would leave us with 5, and 3 from the 4 would leave us with 1, and we would have 4 as our denominator. So again, 10 minus 4 3/4 would be equal to 5 1/4. So here we have some work for you to do. Add or subtract the following: 3 sevenths and 2 sevenths, right? 5 eighths and 1 eighth, 9 tenths minus 3 tenths, 4 sixths minus 2 sixths, 4 thirds plus 2 fifths, 7 tenths minus 2 fifths, 5 ninths plus 2 sevenths, 4 eighths minus 1/4. All right, so some of those are pretty easy to do. Let's do a couple of them here. So 3 sevenths plus 2 sevenths. So 3 plus the 2, this would be 5 sevenths. Okay, we have 5 eighths plus 1 eighth, and 5 and 1, that would be 6 eighths. We can reduce 2 into 6, 3, 2 into 8, 4. So that can go all the way down to 3/4. Then we have 9 tenths plus 3 tenths. Okay, and this would be 9 and 3, that would be 12, and 12 over 10. We can reduce this in a couple different ways. We could say 2 into this would give us 6, 2 into this would give us 5. Then we could say 5, rewrite this as a mixed number to say 5 into 6 goes 1 time, and we have 1 fifth. So 5 ones, 5 ones 5, and 1 6 over 5. Then let's see, we have 4 sixths minus 2 sixths. Okay, this would be 2 from 4, leaving us with 2 over 6. And then 2 into itself 1 time, 2 into 6 would go 3 times. That leaves us with 1/3. All right, let's see, 7 tenths minus 2 fifths. So 7 tenths minus 2 fifths. LCM here being 10. So 10 into 10, 1. 1 times this 7 would give us back 7 here, minus, keep the operation, 5 into 10, 2. Use that 2 to multiply the 2 there, and that would give us 4. And then 4 from the 7 would leave us with 3 tenths. Can't reduce any further, so 3 tenths is our answer there. Let's see, 5 ninths. 5 ninths plus 2 sevenths. Let's fix. Okay, let's make some more space for it then. So 5 ninths plus 2 sevenths. Okay, and LCM here, 9 and 7. Let's say 63. 9 into 63 would go 7 times 7 nines would be 35, plus 7 into 63 would go 9 times. 9 twos would be 18. So 35 and 18, we can put that one side. Let's add these. This would be 13, carry 1. This would be 53. So this is 53 over 63. Okay. Let's go with the next one, which is 4 eighths. 4 eighths plus 4 eighths minus 4 eighths minus a quarter. LCM here is 8. So 8 into 8, 1. 1 times 4 would give us value 4 minus 4 into 8. Let's see. 8. Let's fix our 8 here. Make this a little bit better. Okay. All right. So let's 8. 4 into 8 goes 2. 2 times 1, 2. So we're going to get 4. And we're going to take out 2 from the 4. So we're going to have 2 8s. We can reduce this by saying 2 into 2, 1, 2 into 4, 2 into 8, 4. So we end up with a quarter. All right. We won't do all of these. All right, so let's start with the first one, 16 and 3 ninths minus 10 and 2 fifths. So deal with the whole numbers. 10 from 16 would leave us with 6, right? That 6 would be added to 3 ninths minus 2 fifths. Let's go, this would be 45. Let's make a straighter line here. 45. Now 9 into 45, 5 times 3 would give us 15. Okay, so we have a 15 here. And 5 into this 45, 9 twos would give us 18. Now we have a problem. We cannot take 18 from 45. Okay, so we would have to take 1 from this 6, leaving us with 5, and then add that 45. That 1 now becomes 45 over 45. Okay, and add that 45 to this 15. Okay, so 45 and the 15 here. This becomes 60. All right, so we would have 5. All right, let's put that here. So let's put that. We're going to have 5 and 60 minus 18 all over 45. Okay, so what is 60 now? And you take out 18. 5, we're going to have 2. We have 42 over 45. So we have 5 and 42 over 45. And we could use 3 to reduce these. All right. So 3 into the 42. So if we have 42 here and we divide that by 3, 3 into 4, 1, subtract, you have 1, bring down 2. Okay, so 3 4s would be 12. So 3 into 42 goes 14 times. Okay, and then 3 into 45 goes 15 times. So we would end up with, running out of space, let me just write it here, we would end up with 5 and 14 over 15. All right. Now go ahead and complete the rest. Let's see what you come up with. And evaluate. It says an aquarium has exhibits that feature different marine animals. 5/8 of the staff are male. 5/12 of the staff work part-time. What fraction of the staff is female? Okay. All right. The sharks are fed 3 times a day during the morning feeding. 2/15 of a ton of fish is fed. During the afternoon feeding, the weight of the fish fed will be 1/15 of a ton more than the fish fed during the morning. If the total weight of a fish fed in a day is a half a ton, how much is fed during the feeding at night? Interesting scenarios here. A baby otter was born 3/4 of a month early. At birth, its weight was 7/8 of a kilogram, which is 9/10 of a kilogram less than the average weight of a newborn otter in the aquarium. What was the average weight of a newborn otter? Good questions. The penguin nursery is open 2 times a day, 2/3 of an hour at noon, and 5/12 of an hour in the afternoon. How much time is the penguin nursery open every day? Two kinds of fish can be found in a small tank that is 5/17 of a feet long. The blue fish is 2/15 of a feet long, and the orange fish is 7/10 of a feet long. How much longer is the orange fish? Going to have to find some common denominator type thing here. An octopus weighs 5/6 of a gram. After 2 weeks, its weight was increased by 3/10 of a kilogram. But afterwards, it lost 1/5 of a kilogram in weight as it was sick. What is its current weight? Josh Daly had two meetings, one for 2 and 7/8 hours, and the other for 3 and 1/8 hours. Today, one meeting was 3/4 of an hour shorter than schedule. How much time was scheduled for meetings today? So in this episode, we looked at fractional numbers. We should now be able to add and subtract to compute with fractional numbers. We have tons of questions to look at. Please complete and post here. Take care, and we'll see you in the next episode.